Corley Moore, coming at you to let you know about the vigilantes. Of course, everybody, I mean, if you watch the scrap, if you listen to the scrap at all, you know about the vigilantes. But I want to be very clear and let everybody know we are moving to Patreon. The vigilantes are moving to Patreon. There's been so many people who said, hey, I don't do Facebook. I can't be a part of the vigilantes. I'm not on Facebook. And I get it. We get it. So now we are moving to Patreon. It is independent of any of the social media platforms. It is its own thing. You can join us on Patreon. So what does that mean if you're already a vigilante? Man, go join Patreon. We will stop your payment. We will refund. If you are on an annual subscription, we will refund what has remained. We will make it happen. We are going to take care of you and get you in there. It's already a beautiful platform. So much going on in there. These are the things. If you're not a vigilante, I'm just asking you, why not? Go to the Patreon. It is patreon.com/thevigilantes. And you get access to the vigilante-only swag shop, the Fire Away live Q&As, behind the scenes of the scrap. You influence the scrap on where it's going to go. Member only, exclusive live videos, complete access to all the past archives, all the past forums, all the past Q&As, the 15% off vigilante code for the firehousevigilance.com store, access to the after party, man. I mean, that's every scrap, the after party. It's unbelievable. And of course, the VIP forums where we talk to some of the best in the business one-on-one in a giant meeting where everybody has a voice. It's exciting. So if you're not a vigilante, go be one. If you are a vigilante, go sign up at patreon.com so that you can get it transferred over. It's going to be a fun transfer, but we're making it happen. It's already been amazing today. I think over 100 people today have already signed up, and we just announced it this morning. So go. Be a part. Vigilantes. Patreon.com/thevigilantes. Or go to firehousevigilance.com and you can click the button there. Very, very easy. Be a part. Be one of the cool kids. Why not? Make it happen. Love you all. See ya.
In the demanding world of firefighting, training against real-world scenarios is crucial. Yet traditional training facilities often fall short in providing realistic, versatile, and cost-effective training solutions. Affordable Drill Towers presents a groundbreaking solution. By positioning an affordable drill tower alongside your existing Connex boxes burn buildings, a realm of realistic, multi-level training scenarios is unlocked. This integration has been adopted successfully by various fire departments, enhancing their training capabilities exponentially. Delve into the heart of live fire training scenarios within the Connex boxes, now amplified by the ADT's multi-floor access, providing an unparalleled training ground.
We started looking at Connex boxes about probably 10 years ago. To me, you can't beat them, especially for the price. The affordable drill tower was the same way. We've got 6 floors, we've got standpipes on every floor, we've got more anchor points than you can count, we've got removable floors, removable stairs. We can go into the 2nd and 3rd floor off the drill tower, so whether you want to use it as an external stairwell or a high-rise, we can do all that and mimic just about any type of situation that the members of our fire department might encounter.
Experience cost-effectiveness, enhanced realistic training, versatile operations, easy multi-floor access, and innovative solutions to age-old training challenges. Take your fire department's training to the next level with Affordable Drill Towers. Reach out to Affordable Drill Towers to elevate your training capabilities today.
Corley Moore, Firehouse Vigilance. It is weekly scrap number 248. Tonight's guest is Dennis Legear. He retired as a captain out of Oakland, California, creator of the turbo back pressure device, the 1 3/16 smooth bore tip, matching nozzle pressure GPM fogs to smooth bore project and true hose spec movement, a panel member on ULFRSI's Fire Streams and Coordinated Attack Studies, author of the Water Supply and Hose Appliance chapter in the Fire Engineering Handbook, contributor in Fire Engineering Magazine. Man, he has degrees. He's got multiple degrees in vocational education. He is owner of Legear Engineering Fire Department Consulting. He is an advisor to Hen Nozzle Company and has provided technical advice to some of the largest fire agencies in North America, including Portland, Seattle, Boston, Calgary, and the city of New York. More importantly than all of that, he is one of the smartest people in the fire service, and that's my opinion. He's the type of person that can use porous in a sentence and make me understand what he's talking about, right? It is my pleasure to have him on as the guest for scrap number 248. Dennis Legear, welcome, my brother.
Thanks for the intro. Happy Memorial Day. There is a good conference series that is put out on the West Coast by the San Francisco Fire Department. I think it's on the back of my short here. What's it say? Like Battleground to Fireground. Battleground to Fireground. And they always choose one member of the fire service, usually executive member, and then a fairly high member of the military, including up to I think they had the chief, highest enlisted member of the Army, Master Chief Grippy, I think was his name. So that's where I got this shirt. Tip my hat to the Master Chief there and all of our armed services and those who served.
I love it. I absolutely love it. Thank you for the Memorial Day shout out. Is there anything I missed? Anything you want to add to the intro?
No, it's more than generous. Just trying to stay involved. I think a lot of people know I've tried to stay involved at a pretty deep level over the last decade or so, mainly around water movement and fire stream development, which really were my passions in the fire service. From actually wildland to structural, I've kind of had a rebirth of my wildland chops over the last couple of years, providing advice to Hen Nozzles. That's kind of where I started with their nozzle. And,
love it.
Yeah.
Man, people are already chiming in. You've already got your first question coming at you, so that's already great when it's already starting out that way. Audience, please post your questions in the chat if you want Dennis to get them and answer them. The more you articulate them, the better I can serve them up to him and he can crush them. So please throw them up there. Greg White said LFG, 4 rocker horns and about 18 exclamation points. Tailboard Misfits said, let's get nerdy. 2 rocker horns, can't wait. Cody Brooks said, settled in and ready for this one. Time to go to school, checking in from Florida. Eddie J said, time to nerd out, folks. Let's go. That's with 6 O's. Maybe 8. There's so much. Matt Musican said, LFG, get ready to be nerds. Yeah. I see a theme here. And Josh Everett said, got my journal ready to take notes. Dan Bender absolutely captured it with his first sentence. He said, this may be a scrap that needs watched numerous times. My brain doesn't usually keep up with the Dennis Legear info overload. And I'll tell you this, if you haven't watched his earlier scraps, every one of them needs to be watched multiple times just to take the notes and restudy the notes. So absolutely. All right. All that being said, let's do the important, let's get the sponsors so we can get to scrapping. I was about to say, let's get to the questions, but I have to do the sponsors. Let's talk about those beautiful sponsors. Keyhose, the OG sponsor of the scrap. Check them out online at keyhose.com and follow them on Facebook. Affordable Drill Towers, on a mission to bring you cost-effective and versatile training props like the Affordable Bailout Prop, which allows you to practice window bailouts, ladder bailouts, and ladder high point rescues. They also make the Affordable Standpipe Prop, which you can roll into the classroom where you can do standpipe theory, but then you roll it into the parking lot. You can actually pump realistic flows and pressures. And of course, their mainstay, the Affordable Drill Tower. It comes in several configurations and standard with a standpipe system. Choose from 1 or 2 sets of stairs, integrate it into your existing Connex boxes for multi-story access or freestanding on a slab. All models are NFPA 1402 compliant and gain you ISO credit. The only thing that you can't do on an Affordable Drill Tower is live fire training. Call Steve, 844-55-TOWER, or drop an email to info@affordabledrilltowers.com. FirestationFurniture.com provides a complete line of quality furniture for your firehouse. It is firefighter owned and operated. They understand the strain that firefighters put on furniture and offer furniture that's built to last. Visit www.firestationfurniture.com for more information. And I love their byline. It's an unofficial byline, I think, but it says, quit blaming the recliner, right? And it's a great byline. So absolutely love it. Check them out. And with all that being said, we're ready to get to scrapping. Dennis, are you ready for the questions?
Yeah. Just as a preference, kind of basing this scrap on my FDIC class this year, which was new, which was basically a Firestream development application class with kind of my mindset this evening is just basically volume placement and velocity and key attributes to applying water from the small space to the medium to the large to the ultra large space. Some of the stuff that we should be talking about on a more detailed level in the fire service. So
beautiful. No, and the FDIC class, brother, man. I love the graphic. There's so much to touch on. And that fact, that's the one thing I try not to do too much graphical stuff when I'm talking about when I do the scrap, because so many people listen to it. So I try not to throw up slides that people have to look at. But I do want to talk and start right out the gate and talk about Firestream design, development, and application. I'll let you just kick it off and take it whatever direction you want with your intro, and then we'll go from there. Because you've already got questions stacking up that may or may not have to do with that topic. But go ahead.
Yeah. I think it's important to kind of talk about like an attack package disclaimer here. Key sponsoring it. Card's done a lot for the fire service with training and everything that's going on. But ultimately, the number one person or people that are most important is the firefighters that are using the equipment themselves, right? So based on their knowledge and understanding, how to get the maximum amount of coverage, cooling, and contraction on your interior attacks, how to get your maximum amount of exterior water where it needs to go, different techniques you can use to try to get, some people say efficiency is like a dirty word. It's really effectiveness, right? Per gallon delivered, per person on the fire ground that is manipulating items that move water. How can we get the fire extinguished as quickly as possible and allow gross ventilation, right? Because people get smoked before they're cooked. So the more aggressive we can be with applying water with a better knowledge base, the quicker we can basically recklessly ventilate. And we want to get to that reckless ventilation as quickly as possible. And the only way you can recklessly ventilate is if there's no fire.
Hold on a second. I got to write down 811 because that is a beautiful, beautiful quote when you talk about reckless ventilation. That is such a great way to state it.
You should almost be able to say that on the radio if you're the nozzleman and you're done with your seat. You should go, reckless vent, reckless vent.
Yeah, just be like, we got water on the fire. You can open this thing up.
Yeah. So, and it's funny, just back to that knowledge and understanding component. Like, I was taught several things in Oakland that I don't think are taught a lot of other places. Condensed city. I was always supposed to go to the window. I was always supposed to look across. Often the building next to the building you're making your interior attack on would have siding on fire. So you can do a lot of extinguishment from the seat room, especially our tighter residential neighborhoods or multiple family dwellings. It's a wooden city. Then I was always taught to look up. And the reason I'm looking up is I don't know whether I'm on a gable side or an eave side. And if I'm on an eave side, the next thing I was supposed to do is apply water up into the eave. One thing that we did not do, at least the people that mentored me, there wasn't a heavy emphasis on hydraulic ventilation. And hydraulic ventilation is extremely important. It's been tested, battleground tested, let's say, in places like Detroit. And DC is very well known for it. It's also now been validated and backed up by data in the residential studies and the multiple family dwelling studies from the
UL.
The UL,
the UL FSRI stuff. Absolutely, brother. No, I love it.
Yeah. I would have been a hydraulic ventilating fool now if I was a firefighter. I just didn't know.
Right. And that's what it comes down to, is learning those things that we don't, figuring out what we don't know. And that's the beauty of it. One of my favorite quotes, and I referenced it kind of in your intro, and I use it in my class that I teach at FDIC, because I use Dennis Legear in my class. But he says, once you have water on the fire, you should make the building as porous as possible. And I do love that quote. And that's where I make the mention of the porous, using the word porous. So,
but sometimes I get these things back and I forget that I've said them. Brian Brush put me on a spot about traction and GPM. Like class he was giving, and I was just like, I don't know where you're going with this. And he's
Right.
like, all GPM in the world doesn't mean anything if you can't hook it up, right? Like reaction force. And I'm sure I said it. I just probably forgot. But
Well, you just said something
remember.
beautiful. You just said something beautiful just earlier. You said per gallon delivered per person on the department. Man,
Yeah.
that is a like an amazing formula to run your department by.
Yes.
No matter your staffing.
Yeah. Yeah. You want to try to get, you want to try to get that water where it belongs, and you want to achieve a mastery level skill set. Not only comes through not only being nerdy and reading stuff, but it's also reflecting on fires that you've been to where you could have done a better job. And by the way, that doesn't mean all water is being applied to stuff that's on fire. For example, coming up into a slowly spreading fire in a cubicle office complex, like coming out of the stairwell, and it's got to be very hard for you to get water initially onto the cubicles that are burning. And as sprinklers fail, efficiency goes down. It would behoove you to have the nozzle open and apply water between the plenum, the drop ceiling, and the walls, and kind of cover the floor a little bit. We have a gigantic building, huge exposure. It might be occupied, it might not be occupied, but wetting 20 or 30 extra cubicles in the fire's path is like removing fuel from its path. So, there's value in getting water on surfaces that are maybe preheated or in the path, especially in those larger volume spaces.
Just negating those BTUs before.
And it's hard to burn stuff that's wet. That's just been my experience.
Hey, and on topic, kind of what we were talking about. You just corrected a quote, because there's a quote I that gets posted quite often, that it's a slide in one of my presentations. Man, I'm pulling a blank on it, and you just corrected it earlier. It wasn't even a month ago that you said, actually, here's the rest of the quote. Do you know what I'm talking about at all?
Oh, no, yeah, almost nobody. It's
variables.
Yeah, variables.
We should be inserting constants where variables exist. Yeah,
we should be inserting constants where variables exist. And then I always say, if you're going to insert a variable back, it better have a large return on investment, right? I mean, you can cut down to the bone, like you can get to a point where you're cutting bone, and there's muscle that should be there. I'm not anti-option. I'm just anti lots of options. My kind of like one of the things I think people don't understand sometimes when I'm talking about bulk beds. Like, I don't mind a rig that has bulk beds, both 1 3/4 and 2.5, having some pre-connected 1 3/4 and 2.5. I'm not sure it's necessary, depending on staffing and rig concentration and everything. But I will tell you what is necessary. If you have a pre-connected 1 3/4 or a pre-connected 2.5, you shall have a bulk bed of 1 3/4 and a bulk bed of large line, right? You can pull up with a rig with no pre-connects and do just fine on all fires, short, medium, lengthy, complex, uncomplex stretches, right? A bulk bed will do all of those things and by the way, I would argue that a bulk bed does a 3-length stretch a lot better than a 200-foot pre-connect does.
No, it's hard to argue. It's hard to argue if you actually get out and practice and put in the reps and actually test it.
Well, a 200-foot pre-connect is always 4 lengths. Like there were plenty. I made the mistake with a couple other people in Oakland of making both crosslays 200 feet for a few months. And I'm lucky I still have all my teeth, because, I worked in an area where I thought it would be okay. And then the bungalow battalion guys were crucifying me. They wish they had 2 150 pre-connects. And then we gave them a bulk bed. And I said, now you have it. We gave you your 150 pre-connect back. And if the first line's 150 and the house only needs 50 feet in it, it's only 100 feet from the rig, you can always pull the second line from the bulk bed. So bulk beds are really a multiversal tool, and a pre-connect is not, right? So you can have a rig without pre-connects, but you can't have a rig without bulk beds. At that point, to me, it's just not an engine.
All right. I know. I love it. I love the thing. Okay. Are you ready for your first questions coming from the audience?
Sure.
All right. This one was actually before the scrap ever started, so it's not even on topic, but I want to throw it at you, and you can be as succinct or as in-depth as you want, but he said, it comes from Kevin, and he said, Dennis, can you explain how the pump rating on an apparatus is certified?
You know, it starts at the OEM manufacturer for like at Waterous when they get when a OEM engine comes through, Pierce, Rev Group, whoever, you know, it's all in the pump and design curve. It gets to Waterous or Hale. They do all the torque and numbers. They test it in factory with the known known horsepower and curve and final drive, and then ship it. And then the factory one, don't quote me on how long the UL pump test is, but when you're buying a rig, you're paying for a UL certification. It's the longer duration certification at the manufacturer. Now, that being said, one of the things that this actually brings into focus here is manufacturers do stuff from draft. And one of the things on an attack package to work properly is that you have to pump it properly. And that means your panel should read very accurately. And Kyle Tone, that works in Austin, that's on their apparatus committee, and me with these guys out of the Pacific Northwest, the rigs I've been specking out here, Rick Mosier from Olathe, Kansas, and Taylor Goodman from Powhatan. We've been noticing for years that pump panels, when they're gated, don't read the way they should. And Yakima, Washington just bought new nozzles and hose, and they had Brian Scott out. And when he was gating, he was surprised because the discharge gauge they put on the outlet would read higher than the gated position.
Oh, wow.
So it would, like, you gate to 90 and the actual discharge would be 100, or you gate to 95. So one of the things you have to realize is when water travels quickly through a tube, sidewall pressure goes down. So that's why they say when your LDH is getting soft or your 5-inch is getting soft, you're running out of water, because it's a little convoluted, but water traveling fast through a pipe actually exerts less pressure out. So when you gate your discharge, right now, this is the valve body. And for people who are listening, I'm making a fist, my other finger's touching my fist. That's where the pressure pickup is. When you gate, you create a reduction in surface area, so the water velocity speeds up. So your panel will read lighter than your actual discharge pressure. So the more you gate, the bigger the problem is. Like you can, like, if a city like Tucson, surrounded by hills, a lot of hydrants are 100 PSI, the rig's idle at 50, you're at 150 pounds, you pull some 2.5, you want a 70-pound discharge, you could gate till it says 70 on the panel, but your actual discharge pressure might be 100.
Yeah. 90,
so all the
100,
people that have said that their 2.5s are over pumped, even when the panel reads right, you know, often they're correct. So we have fixed that. You know, I've had other things I've been dealing with, but there will be an article out. Most of the OEM manufacturers understand this now, and it'll be a process over the next few years to get all that stuff straightened out without hurting anyone's feelings.
What was the general fix for?
Oh, it's pretty easy. You just go back. It's like True ID hose from Key.
I was getting ready to ask, is it just like saying true discharge?
Yeah, you just go back to the future. So the reason people like True ID hose, it's modern technology. There's a lot of stuff to it, but basically I remembered thicker, stiffer, bulkier hose. And the rigs, they used to, instead of using the valve body port, which didn't exist, the valves didn't have multiple ports on them. They used to drill a hole in the pipe near the actual discharge, and that's where the pressure hydraulic pickup would go. So we've just returned to the proper place to put the pressure pickup.
Where they're
so
measuring.
now you're way away from the turbulent flow, But you also get another benefit. If there's a lot of bends in the piping and stuff, you don't have that error either. So you get all the recorded plumbing loss, and you also get a panel gauge that will read 100% accurate, right?
So I'm going to try and simplify it for firefighters and myself. It's basically put where they actually do the pickup as close to the actual discharge as possible.
Right. So essentially it's within the pump house still. Like, you could get super crazy and do transducer pickups and put them right at all the discharges. But as long as you're like the rear discharges, as long as you're in a straight run of pipe right where it leaves, it handline flows, that 2.5 going back. I always spec 3-inch, just doesn't have enough friction loss in it for it to be a significant things. You got to do a few tricks on your side discharges. You got to push them back in so you get a nice pipe nipple. So you can actually be, quite a ways away from turbulent water, which isn't really a problem. You can do it as long as you're not trying to brings to another thing. Like everybody's obsessed with 48-inch pump houses or 45-inch pump houses, and if you do a turning radius study, the difference between like a 48 and 50-inch pump house really means nothing. But if you're trying to stuff everything in there and you're like, wonder why your gauges don't read accurate, and it takes forever to get your rig back from the mechanic shop because they got to go through one valve to get to another valve. I'm constantly talking people up in panel size. Like, you're not San Francisco. You don't need a 45-inch panel. You could do a 50-inch panel and make your mechanics day, and you'll have no leaky valves, and your panel will have a nice layout, and everybody will understand it. And you've only knocked a few inches off your turning radius, and you're a suburban fire department. You don't need a 45-inch pump panel and a 27-foot long rig.
I love it. No, I love it. But basically, get past the bends. Is that yours? Is that me?
It was me.
Okay, just making sure. Get past the bends, get to a straight run, as straight a run as you can get before you do your pickup.
Yep. I mean, that's basically
I'm trying to melt it down.
So the reason you don't have problems at factories when you do one leg at a time, one run at a time, is that all of the OEM manufacturers basically test from draft. They have a drafting pit or a lake you go to. So what's that mean? No pump, no hydrant pressure. So that means if you test one line at a time, it'll be fully open. So you'll never get a panel that reads one pressure and then the discharge pressure is greater. That's kind of a mind F, right? As water goes through this tight spot, right where the pressure pickup is, it's going to read light. And then as water slows down, as it gets to the drop elbow on the rear of the rig or anything, pressure is actually going up. So water, the same volume at a slower tube velocity has more kinetic energy than the same volume at a higher tube velocity.
You're talking to a guy who never got a friction loss question right on a test.
Yeah, well, it's more than most people. We're working on it. It'll be fixed.
Right. That's the good news. Is it's becoming becoming industry known.
Yes. And I think once people are upset enough about it, it'll just become an industry standard. Yeah.
Love it. I love the fact that you are willing to fight for those things like True ID. And now we got to come up with a true discharge readings.
Well, I've always, after I got hurt, I was retired. I just wanted a couple retainers. And I remember shopping myself around like branding. Nobody wanted me. Like an Eddie Bauer pump panel. We could have just a Legear pump panel. It reads right, So
with some leather insets and some wood.
True panel.
Yeah. Legear true panel. I love it, man. Looking forward. Okay. Nick Barone wants to know, moving big water. My question is about using a hydrant valve. When should they be used?
Right. That's a good question. It's another one of those things. Like if you're a Ford lay LDH department, and you don't, that's Uncle Ray asking if the scrap's on. So I'll just say now. So. Then I'll mute my phone. He's the
one you're waiting on. Hey, Uncle Ray can interrupt the scrap anytime.
So you know what, when do you want to use this? And it'll be dependent on your supply side. But I really think about it like your single family dwelling, if you look at NFPA 1710, Brush can quote this stuff off the top of his head. I think they say like 500 gallons a minute is all you need in a redundant water supply. It might be 400. Don't quote me. Like Brush knows the stuff left and right, and commercials 800. So when you look at your residence, you look at your hydrant spacing, and you go, if you're in 5-inch hose and you look at 500 gallons a minute, whatever that would be in 5-inch hose, here's an old Akron slide rule. So 500 gallons a minute in 5-inch hose says 2 PSI. And we know 5-inch hose is bigger than 5-inch, so it's less than 2 PSI. You could be like 700 feet away from a hydrant, and even a 30 PSI hydrant would still have 15 pounds left in the barrel moving 500 gallons a minute. So the short answer is, for your lower volume fires, it's almost never, right? And then, so for your larger fires, it'll be often. Now that might not be true for a department like DC with 3-inch hose, right? And older hydrants. They might drive away from a hydrant up a hill, and the hydrant's only a 40 PSI hydrant, and they've driven 400 feet away from it, and they're uphill. So now you have head pressure, and now they're trying to flow a couple 1.5 inches, and it's 250, and the friction loss means something. You're gonna have to pump it.
Right.
Now, the time you always, whether you have a 4-way valve or hydrant valve or not, the time you always want to use them is multiple alarms on larger bodies of fire. Because remember what we were talking about, pressure pickups. And velocity, as velocity goes up in the water mains, right, residual pressure goes down. So that's why you see like 1 master stream's good, 2 master streams good, 3 master streams so-so. Someone tries to flow a 4th master stream's no good master streams, right? It doesn't mean the water's not available in the mains. It just means you have now used all the kinetic energy. The fire engineer that designed the water main system never expected the residual pressure to be your fire flow at major incidents. And as a general rule of thumb, if you're not placing pumpers on hydrants at large water flow events, 3 nearest hydrants, 4 nearest hydrants, you're giving up about 50% of the available supply. So it's substantial.
Wow.
The other things is pumps push water. They don't pull water. So it's, that big outlet on the hydrant's a steamer for a reason. As you push it. Now, that doesn't mean you have to have a 4-way valve. Someone will probably correct me if I'm wrong, but Minneapolis and St. Paul, I think it's Minneapolis. Minneapolis always goes straight in, does a tank attack, and the next engine either backs down or hand pulls, and then they put a pump on the hydrant. San Francisco is another great example of a city actually, I don't even think they have a rule for commercial fires. It's commercial, large body fire, any body of fire. The first 2 engine goes straight in and shall apply water, right? It's trying to act like a time machine, whether it's a resident or a commercial, put time on the clock.
Reset. Yeah.
And then essentially the next engine parks on a hydrant, and they hand stretch between those rigs. And that's one of the powerful things about like a dual bed of 3-inch. City of Seattle, if the engine's within 100 feet of the hydrant, they put it right on the hydrant. And if it's not within 100 feet of the hydrant, it's a major incident, they put a pump on the hydrant. Then you look at somebody like the East Coast, Camden, New Jersey, right? They have hydrant valves. So it's just a matter of physics. I think I've beat that question up enough.
I love it, bro. Great answer. Thank you for it. I won't even go into 3-inch, 5-inch. I'll go to the audience questions instead of my questions. Hold on, coming at you. Eddie J wants to know, what are the main benefits of smoothbore on elevated master streams instead of automatic fogs?
Honestly, it's probably not one that most people have heard. The automatic nozzles plus or minus 15 PSI through its demand curve. So if you look at a curved chart and you look at like a 75 PSI nozzle, which is one of the major manufacturers make them at 75, it really means your actual nozzle pressure. Actually, it's even worse than that. Your actual inlet pressure could be 60 psi, and then you got to minus all of the friction loss in the waterway itself, because the fog nozzle is the appliance. You might end up having a discharge velocity of 60. So like an automatic nozzle at 80 and a smoothbore nozzle at 80 do not equate to the same stream velocity. So that's number one. So you don't hit a true discharge pressure. Number two is it's a solid column of water and less of it is exposed to the radiant heat column. So let me take you inside a building, right? One of the things that people don't understand inside residence, like everybody, like Hen's bladed pattern. Let's just talk patterns. Let's not talk manufacturers.
Okay.
Let's just say blade, straight stream, fog stream. And by the way, I don't really believe in the 30-degree fog. Somehow it's in literature. Let's call it realistically. No one's running them better than 20 degrees. And then let's say solid stream. All right. So the fog nozzle and the straight stream, it's an impingement baffle design. So water goes through the center of it. There's two 90-degree turns, and doesn't really matter whether it's in the straight stream position or the fog stream position. You're hitting those impingements, and that's the way it's forming its pattern, right? A straight stream just basically it's refigured in. So it's high turbulence, smaller droplets, and even in straight stream, as you go through a thermal column, it's more likely to be disrupted by wind and heat and radiant heat in convection columns. So it's more likely to be stripped away than a solid stream. So now talk about reach inside a compartment. And I've seen people now going around like tying ropes to smoothbore nozzles and pulling them out taut and showing different angles and stuff. I kind of started doing that maybe 4 or 5 years ago at Water in the Fire, and it's kind of gotten out of that conference because people get there. It's not that I was trying to keep it secret or anything. I personally myself hadn't really come up with a distance that I felt that a smoothbore nozzle will go in heat.
Right. No, and even I was in that class, well, one of them where you were stretching those ropes into the room, and you said there's no way to know inside of a fire how far it actually goes. These are best guesses.
Right. So I wanted to build like the UL had a stream study that was supposed to occur, and essentially I wanted to build a gigantic oven,
right,
horizontally, and I basically wanted to apply water inside a giant oven at different velocities and volumes and just see how far they can go. I will tell you this, that I know for sure that the vast majority of instructors are grossly underestimating true reach of a solid stream inside a heated environment. So, so like, let's just make perfect common sense here on the scrap. Let's say you go out to a drill ground and you have a 7/8, and let's say it has 60 feet of reach, and you put an 1.1/8 right next to it as 70 feet of reach. All right. So in a no heat environment, let's say breakover is, I don't know, 30 versus 40. All right.
Fair.
The vast majority of the reach credit 2.5 gets past 1.75 is post breakover.
Oh.
So let me dig into this a little bit. If you have a solid stream and it's flowing along through a heated environment, and there's only a couple square feet of total surface area in that stick before it hits breakover. You see what I'm saying?
Yes.
At 50 psi, it's traveling at 60 miles an hour. So like, if this ruler here is my solid stream, it's going through the room, right? And this is at 60 miles an hour. Do you expect to lose much volume when it's in its condensed state?
Right. Right. No.
The answer is no.
Right.
Like, I would almost argue that it would be within the measurement error at 1,500 degrees Fahrenheit. Like, you wouldn't even think about it losing any volume. And we've had instructors for years say, 7/8 just evaporates in like 20 feet in a really high heat condition. And it's all these guys, they're looking at thermal imaging. And
is that just anecdotal and
I have no idea where they got it from. I'll tell you what, the UL burnt some strip malls up in the coordinated attack study, and it was just an experimental commercial ad at the end, right? They really wanted to go in. Their commercial fire study didn't get funded by our federal government. Shame on the federal government. I'm sure it was written very nicely and submitted. One of the things that Lieutenant McCormick did before he left the FDNY is he allowed people to, they changed the engine book, and at like bodega fires and small commercials, I don't know the exact definition, they're allowed to stretch the 1 3/4 now, right? And a lot of people like lost their mind over that. Well, we used a 3/4 inch in one of those fires. It was a 2,500 square foot unit. It was roughly 30 by 80. Mike Alt was on the team with the nozzles on it, and they had a fuel package in the middle of the room, and they were doing vertical ventilation. Andy Ruiz was there from LA City, and they said, well, what do you think, Dennis? You think that it's going to have good reach? And I'm like, man, I think from the front door they'll hit the back wall. And I knew the fuel package was in the middle, and I'm like, they're going to have no problem collecting the fuel package. So one of the things we told Mike is, hey, before you back out of there, if you start thinking you're in there and it's not going well, Ray said it, I said it, other people said it, hey, start low, sweep back and forth, and come up. Because in a no visibility environment, which we created in there, and no tick, what could you easily miss with a dot? If you have a 7/8 and you're running around there, what could you technically miss?
Yeah.
You could miss the fuel package. They missed the fuel package and missed the fuel package and missed the fuel package. And he said he was backing up, and hopefully he'll listen to this so he can verify it. But then he went back and swept it, and it went right out. So what was the next thing for me to do as in someone who's interested? I went straight in. What was I looking for on the back wall, Corley?
Hit me.
I was looking for, is there any evidence that the stream made it past the fuel package and actually started coating the back wall?
Coating and getting
there was marks all over in the soot line past the fuel package. So when Kyle was dealing with the bladed pattern, and we had him set up for a 50-foot advance, and he was very worried that it wouldn't make the fuel package, I was like, I have zero fear here. Like, all those drops are traveling about 60 miles an hour. They're all large. We're not going to have any problems here. Too many people talk about reach when they should be talking about coverage. What's the hardest thing to do inside a residential compartment, Corley?
Hardest thing to do?
I'll give you a 7/8. You go in, it's a 20 by 20 room. Go.
Yeah, you're hitting it with a laser beam. It's hard to cover.
It's the smooth bore stream is non-pre-distributed, right?
So it's
basically you have to use the surfaces to your advantage. Why do you start into the overhead?
You break up and carry and flow. I mean, yeah, run and run.
So you got a high heat condition, right? And frankly, it's one of the reasons you start in the overhead in residential is you expect a good amount of lift because what? Because the ceiling height's not that high. Would you expect a lot of lift if the ceiling height was 30 feet? You think you could contract everything up there?
Yeah, if you're talking 30 feet, that's a whole different ballgame.
Yeah, the answer's no, right? So the residential high approach is to get water in the overhead, but more importantly, collect the ceiling and start what?
Well, the gas compression.
Slowing your water down, getting it to fall out and coat all the walls. And then why are you working a pattern? What do you want to collect between you and the far wall? All the fuel package, all the live load that is in front of you, right? So coverage. Remember what I said I wanted to talk about today? Volume, placement, and velocity. I don't want my nozzle pressure to be over 50 PSI in a handline. Frankly, I don't want to give up GPM for nozzle reaction, first off, but I already have a hard enough time keeping water where? Close to me. It's already traveling fast enough. I don't need my water to travel faster. In fact, when I sent my video in, it's on my YouTube channel, when I sent my video into the fire attack study and I had a pattern I was working, it came back no discernible pattern, Corey. And I like, well, anyone who's watched me work a nozzle, I do these like really aggressive corkscrews. and I go into the overhead, and then I bring the nozzle down really quick, and I crash right in front of me in corkscrews. If you do a series of corkscrews through a room in front of you, what are you going to collect? You're going to collect the floor. You're probably going to collect part of the couch and back. And then if you work back with a series of corkscrews, you're probably going to collect the other thing. I see two problems quite often when I see videos on the internet. And James Nisbet, super great guy. He's out podcasting. I love seeing people move. The next generation should exceed the previous generation's knowledge base, right? Jay Bonifield, Nisbet, all these guys that are out there, they're nerding it up. Kyle Romagus are reading it, and they're moving forward. He posted a thing to Indian Company Insurrections from Clackamas, which is a dialed-in fire department. They're going to the prop, and it's like into the overhead, into the overhead, into the overhead, into the overhead, room to room to room to room. And I'm like, I'm not going to comment on this without calling them first. Like I called them, I said, hey man, I can't let that not go without a call, because everybody in the comments is like, it's the greatest thing. It's so awesome. It's awesome. This is cool. Man, they're really nailing it. And all I saw was like, that's horrible suppression. Like they went into a room, worked the overhead, backed out, and went down the hallway. What did they miss? They missed the fuel package, right? They missed most of the fuel package. You execute how you what? Train. You execute how you train. So like, back to patterns, people go like, what are you trying to solve with the bladed pattern? By the way, it's not what I'm trying to solve. I didn't even like it. I just want to do the wildland stuff. I was like, I don't know if it's going to be inside. The more I see people use it, the more it solves the coverage and all of the things, you know, some people that shall remain nameless want wall ceiling wall. I want squash toes and corkscrews. Ray was kind of a side-to-side guy. And notice, some of the stuff that Ray did way back in the day, 20 years ago, the bounce in the hallway, the pulling the stream back, right? Let me give you an example where you should never start into the overhead. Who has multiple family dwelling fires?
Yeah, absolutely.
All right, clean hallway, fire rated door. And the irons are working on it. It swings open, and it's not a back bedroom fire. It's what? It's an open floor plan, kitchen completely off, L-shaped couch straight in front of you, and you're in the door is the nozzle. Where should you spend a lot of time? Not in the overhead. You might want to start there for a second, but where are you? Where have you been warped to? Because of the building features and the construction, technically, what are you right next door to? You're at the seat of the fire. The fuel package is right in front of you. There's a great video from the UL burns in Cobb County where they swung the door open, and it's exactly that. The guy spends time in the overhead, and he just looked like a Christmas tree in front of the door until he lowers the nozzle, right? So coverage is super, super important. So back to master streams and automatic nozzles. We'll circle
Full circle. I like it.
We'll circle all the way back. The constant gallonage nozzle means you're stuck at a single speed. And one of the most valuable things that you can get out of a smoothbore nozzle that is correctly sized for master stream development is velocity. And Matt Scallion, who's not on the circuit anymore, but was kind of Kurt Isaacson's right-hand man. I wish I'd come up with something so smooth, but he says, I like my inside water slow, and I like my outside water fast. You want to get it through your thermal column? By the way, if it's going too far, what can you do with a fixed orifice nozzle? What does a fixed orifice nozzle not do?
Adjust.
It doesn't preserve reach. What's an automatic nozzle do? It always preserves reach. Who's had a master stream that's going over your objective?
Yeah.
And what happens when you turn down the throttle, you try to reduce nozzle pressure on an automatic nozzle? What's it do? It keeps reach.
Yeah, keeps doing what it's doing.
Yeah. I've multiply manipulated tip pressure to my advantage
All right.
is an assault. And by the way, I think if you can hit what you're trying to hit, nozzle pressures below 100 psi for master streams are bullshit. There's really no need. I would rather have a smaller tip. Remember, back to volume. You're a chief. Let's say you have 3 hydrants and each hydrant's good for 1,500 gallons a minute, and you have a large fire. So that's 4,500 gallons when you're at 0 for the scene.
Tracking so far.
Okay. Would you rather have 3 800-gallon a minute, really nice, high-pressure master streams doing work? Remember, for every 100 gallons a minute that's delivered to the service, it's about 1 million BTUs per minute. So that would be, each one's capable of suppressing 8 million BTUs per minute, as long as you're hitting what's burning. And that would leave you what? 2,000 gallons a minute for what? Handlines and little monitors and stuff. Have you been to the fire where you look around and there's some numbnut with an automatic nozzle that had a high compound pressure? He keeps throttling up. What's that automatic nozzle doing? It's greedy. Yeah. It's going to just keep taking. Then you want one what for your exposure? 1 2.5-inch hose line. What do you not have, Chief?
No water.
You have no water. I don't need a 1,250 or 1,500 gallon minute automatic nozzle not doing anything anyway. I want a 2.5-inch handline saving the house that's not on fire yet.
I love it. Hey, brother, this is amazing. I wish I could keep up. The questions are awesome. I have no answers for you half the time. And I think actually, yeah, Mark alone has it best. Corley, stop buffering. Absolutely, man. I'm trying to keep up. I'm trying to just to soft serve Dennis. So keep the questions coming. It's awesome. I will do my best. But absolutely. John Novak, he wants to know, where did the recommended nozzle reaction of 69 PSI come from, or what was it based on? So
he meant 69 pounds, right? And by recommended, I think he's talking about inch. I'm just guessing. Inch and 3. It's a 15/16. It's 70 pounds nozzle reaction. The 15/16 nozzle, obviously, the origin story is the city of New York. They were 1.5 inches. They were 1 3/4 inches, and then they made 1/8. Somebody must have overbore it. It's mentioned in Fornell's book is like, half the body weight of the average fireman. That can't be true anymore, right? So I don't think it's like another one of those things where, back to what I want to talk about, volume, placement, and velocity. The 7/8 inch flow, the 160 at 50, that's 63 pounds technically, right? And they just did a research study. Dak, I will mess up his last name, from University of Illinois. They did a nozzle kickback study that they quoted Aaron and myself and a few others, and Sammy Vega was involved in it, and it talked about the bend in the hose. And if you take one of my spec and layout classes, I talk about the 72-inch nozzle bite. Like Brian Brush, for example, all those videos of him doing like a handstand with 2.5 and it's flowing, or has it just on its boot. That's because there's a certain amount of water mass and material mass and weight in the last 72 inches that is counteracting the 99 pounds nozzle reaction of 1 1/8 inches. And I believe he's a big fan of the 1 3/16, which is at 50 is really 110 pounds. If you take the same nozzle and you put 1 1/8 on True ID 2.5 made by Key, people are going to say, they're going to pitot it. They're going to have a calibrated flow meter. They're going to say, hey, it's the same volume. Why does it feel like so much more nozzle reaction? There's actually less weight in your counterbalance. There's less water per foot, less material per foot. It's nice and stiff. Some people might say that it's too stiff. And I'm like, you look at Super 2 and at 1 1/8, Mercedes products a little more whippy. Like you can go back and forth. I personally think once you shrink down the diameter and you're trying to go for that 250 flow, I was focused on giving as much of the pipe as possible, because what's very important, placement. And how do you get placement? You get placement through balance. balance of all of these things, like weight of the hose. So, you know, I know Key's a sponsor, and I obviously done consulting work for him. Absolutely. Sniper was made because True ID didn't fold extremely well. Is True ID a bad hose? Chief Morris is like, I love it. You can grab it with gloved hands. He's like, I don't want hose to lay flat. I like when you throw down, you can see all your ears. Another guy from the DC Beltway might not like it because it doesn't fit flat on their shoulder, right? So these are like baking cakes and recipes. That 70 pounds, I'll say, is the highest nozzle reaction I see for a single person to be able to flow and move in advance. If you're a 2-person engine company, I'd rather have you at 150 gallons a minute out of a 7/8 than 180 gallons a minute out of a 15/16, because I think you'll flow and move, you'll apply more water. Back to that amount of water delivered. But it's not only that, it's coverage. Are you doing your coverage appropriately? This device that I did the turbo, right? And I think I've made some people upset with this device. I'm always trying to come up with solutions for people. I realize that there's a lot of the fire service that only has a 2-person engine company. Would you say that's fair?
That's fair.
Okay. So what's half of 50, Corley?
I can do this one. 25, baby.
And that's 50%, right? It's 50%. So 75 is 50% greater than 25. If you put this on whatever nozzle manufacturer you want, it's designed to create 25 pounds friction loss at 160. You've added 50% more mechanical back pressure. If you're a 2-person engine company, who's getting your kinks?
Yeah.
Nobody.
Nobody.
When you charge Dallas, great fire department. I have nothing negative to say about them. They got some True ID. There's a famous video out there of some guys getting their gear all saturated on a porch and heated up because they had a bunch of kinks on their initial charge. I'll give you a couple advice on True ID. I love it. It's a great product. You better charge it extremely aggressive. And you should grip it and rip it open. My personal preference is to charge in RPM. Why would you want to charge in RPM instead of PSI, Corley?
Just the volume? What are we talking?
So it's the pressure setting on the governor. What would you want it in cruise control? Let's say you know you need to pump at 110.
I feel like I'm being quizzed for a promotion.
Yeah, I know. It's always like how I run my classes, and you unfortunately are on the other side of
I'm the only student.
You're the only student.
Go ahead.
If you put it in cruise control and it's sensing pressure and it runs into the first couple kinks and then it sends a pressure signal back hydraulically, right?
Right.
And let's say it runs into a couple kinks and you're not getting water. You set it at 135, 35 plus 35, 70 plus. You set it at 130, and the guy didn't lay it out super smooth. It senses 130 pounds back to the panel. What's it going to do to the RPM of the motor?
Down. Yeah, it's going
to throttle down.
Right.
Who's been there? I know there's been people on this radio that are listening that have been going around knocking out kinks when the rig's essentially idle. Because if you have no water at the nozzle and you set it for 110, let's say Key Combat Ready or any very large hose, Mercedes EXO or Pond Gladiator, it's a very big tube, right? So you have a very low pump discharge pressure. Let's say you only need to pump at 90, right? So it's 20 plus 20 is 90. So you put it in PSI mode, you hit 90, it hits the first 2 crappy little kinks, it gets 90 back to the panel. Who's been there as you're knocking kinks out, the water's just kind of slowly, lazily, oh, it's got to the next kink, I got to go get it.
Very lazy, yeah.
Right? That's because you charged in PSI and not RPM. And by the way, who are you protecting? What's the PSI mode for? It's to protect the second person on the second line. If you pull up and you're making your initial charge and you've charged in PSI, I would argue you're doing it wrong.
Wow. No, I didn't even thought about it. I mean, I don't think a lot of people have thought about it. It's a, wow. Okay. I failed my test, everyone.
So the turbo, back to the turbo.
Turbo.
You get 21 feet per second. It doesn't screw up the Freeman ratio. It creates an environment where you have 50% more mechanical back pressure back to the pump. Have you ever run a pump, Corley, and had to gate it? You get a 70 PSI hydrant? Imagine most of the time you're never going to have to gate the pump again. So if you show up, you charge an RPM, once they get pressure and you go to 135, if your net pump pressure is below your hydrant pressure idle, the governor will always work. So it fixes a lot of the pump pressure issues around the governor. If you're not chasing kinks and you're not gating the rig, by the way, we talked about earlier in this show, is your pump panel going to read properly when it's gated based on the way they're plumbed now?
No, the way they're plumbed now, no, and that's a huge takeaway.
No. So guess what? Is it easier for me to go around the country and fix everyone's pump panel, or is it easier for me to do this? And by the way, most people don't have a 4-person engine company or a 5-person engine company.
No, absolutely.
This fixes a lot of problems. I'm not interested in being involved in stuff that doesn't fix material problems. And
go ahead. Sorry.
Honestly, I think, key firos might be like semi-flustered with me because I'm using their product and I'm like, hey, Sniper with this is the next best thing. And then I go, with the bladed nozzle, it's even better, right? And they go like, well, you're saying something about our product. It is. It's their company. It's their product. I could say the same thing. Kraken EXO or whatever. Does a low-pressure hose like Sniper need 25 pounds of back pressure to work properly? No. But if somebody takes this device and puts it on Eco 10 or 8D from SnapTight and says, I never have to buy premium hose again, I think the hose manufacturers have failed. What's some of the other important aspects of premium hose, Corley, other than low pressure?
Well, there's the kink resistance in theory.
Kink resistance. So it's a leg up. So anything this does to help Eco 10, it does the same or better to something like Sniper. But what else? It's heavier hose that's going to burn through less. It's going to get less damage. You can train with it, right? So
it's better. It's better hose overall.
It's better hose. It would be, it'd be like, I don't know. We could come up with an analogy. I'm not going to come up with it. It's an equal level playing field for all of the small handline specs. And, I'm going to tell you right now, there's going to be a 2.5-inch version because I know all of the agency. Why does Dennis not like 2-inch hose, Corley?
Why does who? You?
Yeah.
I get to ask you back. Why do you not like 2-inch hose?
Because it's super whippy. You can't get a good commercial flow out of it. You can't get a good 250 out of it. I'm not really good at flowing below 250. Bill Gustin called me the year after Metro Dade Miami went to 2-inch combat ready with 2.5. He wrote that beautiful article with the 1 1/8 tip. And he said, hey, what I'm really looking for is between 40 and 45. I'm looking for 250-ish. I'm not looking for 265 because it's a bear. It's a bear at 265. The nozzle want to hit you in the face. Shannon Stone, same guy. He calls me up a year and a half later. He's like, you MFer. Now there's True ID 2 1/4. It worked with 1 1/8. And it's actually at a lower friction loss. He's like, look what you've done. Well, I can go back now, and whether it's Key's product or someone else's product, there's a lot of enhanced 2-inch hose out there that's 2.2 inches, combat ready ish, probably Gladiator 2-inch. Those engine companies that only have 3 members on it that can now add a little back pressure to their 2-inch line and flow a true 250, it's going to be a materially positive thing for the American Fire Service. That's called progress.
No, I love it. And here's what I'll say. And one of the best things I love about the turbo is I think the major holdup of departments, organizations moving forward with a proper attack package. That is mating a good hose with a good nozzle and understanding the combination. A lot of people just slap a smooth bore on the hose they have and they're like, hey, this kicks me in the face and I don't like it. You know what I'm saying? And that's just ignorance that exists. But what the turbo does is it allows people to slap this in between that low quality hose and that nozzle, and then have it perform as it should, which is a nice stopgap. But it does not mean that it is premium hose.
Yes, and my suggestion to anyone doing a hose and nozzle study out there, that is in a large department or in a department that they can't. By the way, my official position would be you got to address hose first, right? And for example, I liked True ID better than Sniper, just because I like how stiff it is. It does. I actually wanted it, and you can talk to people that originally designed it. I wanted it to be 40 psi per 100. 40 plus 40 is 80 plus 50, right? We're at 130. Why did I want it to be 130? Most hydrants are between 60 and 80. You add 50, that gets rid of your having to gate. We couldn't get there. I wanted to put little speed bumps in the rubber liner. Do anything, make it have more friction loss, right? Friction loss and tube velocity are non-correlated at the same diameter based on liner smoothness. By the way, liner smoothness is not even anything anyone talks about.
Did you just hear what you said?
Yeah. Yeah. But my official position would be, if you're one of those fire departments like San Diego or LA City's doing a hose and nozzle study, Portland's in hose that doesn't really work well with 50 psi nozzles, so they're in the dreaded 150 at 75. Why do I call it the dreaded 150 at 75? It fixes a lot of hose problems, but what does it not do? It has 75 pounds nozzle reaction, 70 pounds nozzle reaction. So what does it often scale down? So now you're under 150.
Yeah, now you're cutting down. Now you're not even getting your water flow.
You put this in any manufacturer's 7/8 or 160 at 50 or 150 at 50 or whatever. You put this in the back. Do you think a 150 at 75 nozzle should ever be sold again?
Wow.
It's been made obsolete.
Yeah.
It's dead. You can do a graphic. You can do a patch with the 150 at 75 nozzle, which, by the way, was the most popular fog nozzle in America. And Chris Martin or those guys could weigh in sales figures. They say the 160 at 50 outsells them now. But right now, in the American Fire Service, there's more 150s at 75s going to jobs than there are low pressure fog nozzles. Why? Because of hose issues. This fixes it. But back to my position. If you're doing a hose and nozzle study, what's allowed now is you can keep your crappy hose, buy a single length of good hose, buy a turbo, buy a nozzle that makes sense, whether it's 15/16 or 7/8, use this device, and then write a nice hose spec. And through attrition, what's a fire department should buy every year? A little bit every year.
Some hose, depending on your time.
Every few years, depends how big of a fire department you are. So in other words,
we're every 10. We're every 10 we replace everything. But
yeah, through attrition, you can get to where you need to go, which is amazing. No,
and and all those other qualities besides flow that we're talking about that matter.
Volume placement and velocity, right? Volume placement. The turbo's pro volume because it's anti-kink. How many kinks do you think you've laid a hand on or seen in your career, Corley?
Kinks that I've personally, just as a chief, I don't know. I couldn't even count just as a chief trying to take out kinks.
Right. So, and then think of your entire fire department, or think of a gigantic fire department. Think of a huge department like New York City or something like that, right? They're stretching from their stretch bed. How many kinks they've had?
Yeah, absolutely.
In their entire thing.
Uncountable.
If they adopted this, which I don't think they will, but if I had any druthers here, I'd say it would be smart. Guess what? There would be 50% less kinks. From this moment forward, there would be 50% less kinks. So if they did 2 million kinks in the last 150 years, there would only be 1 million kinks in the next 150 years. That means something.
It's a powerful argument. A powerful argument. I got this one coming at you from Mark Alone, who has been busting my chops a little bit in the chat, but that's okay. Dennis, do you see 1.5-inch attack lines making a comeback due to all of the advances in hose construction?
All right, so this is another thing, like it's covered in my class. And I totally get. I was in 1.5-inch hose at 95 GPM, roughly at 100 PSI for a number of years, both in Oakland and in another department before I got to Oakland. Everybody likes. It's only about 50 pounds nozzle reaction. There's almost no kinks. Could have I made this do 100 PSI 50 PSI back pressure? One of the things, 100 PSI back pressure is unlikely to kink Corley, but once it kinks, what's it exclude more of? Water. It's a tighter kink. It's one of those things. This porridge is too hot. This porridge is too cold. This porridge is just right. Right? Like, we can get crazy with this stuff. 1.5-inch hose, modern 1.5-inch hose is 1.65 dry plug at the factory. Mercedes, True ID 1.5-inch hose, whatever they call it, plugs at the factory 1.65. I think it's EXO. And when you charge it, it has a 1/10 of an inch expansion factor. So it's 1.75. They're like, look at how low the friction loss is in it. Montgomery County uses it in the Beltway. And it's really whippy. And then you try to get 150 gallons a minute through it, and it's too whippy at a 50 PSI back pressure. So guess what nozzle they're in? The dreaded 150 at 75. So now they're trying to get 150 out of it, and they have 75. They got to choke up on it. If you choke up on it, do you have good placement?
No.
You don't have good placement. Now, what you can do, right, on that hose, you could put a turbo, and you could do a 7/8. Guess what? The turbo allows the 7/8 to be at what pressure and still not whip? Like 40 pounds. You can have a 7/8 at 40 pounds. You still have an extra 20 pounds of back pressure back this way. So that video I did with me without me getting sued, Michael Abishan owns the company, North American Fire. He's a true OG of the hose deal. Polytough, it's 1.5-inch hose. It's a lightweight hose. With me, that video I put out with the turbo, with me messing around with it, it wasn't because I was advocating for it. I was trying to show someone how powerful the technology is, right? And why I don't think it'll bring 1.5-inch hose back is the nominal weight difference between 1.7 and 1.8 at a 1/10 of an inch. Like, we could do the calculation. It's going to be like maybe a gallon or 2 gallons of water over 100 feet. We're talking about like 8 pounds. It's not the difference between 2 1/4 and 2 3/4. And then there's a lot of additional friction loss. And then the water is going to be traveling extremely violently through the hose, which is going to bring sidewall pressure down. So there is a balance. Now, that being said, if I worked in Montgomery County and I had control of the purse strings, I'd want to get rid of that 150 at 75 nozzle, and I would want to buy a back pressure device, and I would want to drop my nozzle pressure, get the nozzle out in front of me, and get water mapping. Would it make their existing 1.5-inch spec work better? Absolutely. But you could say that about a bladed pattern too. A bladed pattern in a residential compartment is always going to capture the couch quicker. It's always going to be, I felt like I had so much bias around it, Corley, that I didn't realize why are we working patterns inside residential compartments?
Water placement. I mean, that's what we're working on.
Why is it? I got it listed like I have this slide, the tack package disclaimer, because so many people's feelings were hurt. O patterns, D patterns, T patterns.
TZO.
Why are there all these discussions? Corkscrew patterns. Why my pattern's not technically a pattern? What are the patterns granting you access to? Coverage. It's inside the box. It's dead center of the box. A pattern that enhances coverage, it ain't outside the box. It's fucking ground zero. It's dead center. Prove me wrong.
No, yeah, I'm trying to catch you up with our Kyle Romiga said. Well, he's talking about the turbo there to smash the stream and break it up. That is the reason for the patterns. The TZ and O is to smash the stream and break it up once it hits the surfaces.
Of course. Let's take Have you ever advanced the line to like a master closet, like, or a smaller room?
Sure.
What's the quickest way to just make sure you've knocked the piss out of everything in there? Half bail.
Okay. I don't know
If you're in a high rise or an office space and it's cubicles, and you get in there and you start working a pattern, you're going down that little cubicle hallway, right? And I would be working my pattern left to right because I'm trying to pick up what? Trying to pick up all those door edges on my advance. I'm not going to work the overhead very much in a commercial because it's the cubicles that are on fire, and what's above me? A black void of piping and fucking drop ceilings and wire chases. There's nothing to extinguish up there. It's nothing but a hydraulic brake on my water. So now, if I get to a cubicle, a bunch of cubicles that are on fire, when I turn into the cubicle, am I going to leave my 1 1/8 nozzle full open? Does that make any sense?
I mean, I'll be honest with you. That's probably what I did.
But does it make any sense?
But I was fired up. But I get it. No, it might not be the most tactical, best decision, but it might be what I did. I don't know if I would have half bailed at that point. I might now with a little more knowledge.
Go to an RV fire outside or a deck fire outside or something like that, right? And some fire departments run their smoothbore nozzles on their car lines or whatever. What do you see guys do often? They have visual cue. They're outside. They got the RV on fire. They use what? The reach of the stream to like get it out, get some in the windows or whatever. And what's the first thing they do? They half bail when they go up, when they're putting the nozzle inside and stuff. It's all about coverage. A bladed pattern gives you coverage at full volume.
No, I can't argue, brother. I can't argue. And there's a lot of people talking about it. Well, I'll bring up a couple things that I've heard over and over, and I'm sure you've heard them enough. But one is like the turbo. You got the turbo.
Yep.
It's got those veins in it. People bring it up all the time about the veins. Yep. Talk about them.
Well, I didn't come up with the shape a hydraulic program did. One of the things that I wanted to make sure is that it didn't take away a lot of the reach of a solid stream. I think that's very important, especially when you're applying water from the out. I think reach in the 2.5 inch hand line is vastly more important than reach in the small hand line, mainly for applying water from the exterior to the interior of commercial spaces and breakover and stuff like that. So the veins are in there to basically create some eddies and have the water become more laminar and less turbulent again, because it's going through this restricted orifice. And, you wouldn't want to add friction loss to a standpipe attack package. Now, unless you did like an infrastructure survey and all your outlets are 150 or greater, hey, have at it. This is not what this device is for. It's for rig stretches. And essentially it's to make rig stretchers save more lives and property, less kinks, easier to handle. Imagine one thing that people get really, you can tell the difference between True ID and Sniper at 50 pounds nozzle pressure when you're the backup and you're feeding it forward. True ID is a stiffer hose. Now Sniper's good, it's just not as stiff, right? So this makes that backup man's job a little bit easier. But again, like something like Sniper, you don't need this, but then is the guy properly pumping it? And you could say that about everyone's hose. Now back to the deals. Is it a clogging issue, right? So right. I talked to Greg.
I think that's everybody's main concern, because it's so long. People said, hey,
I was against stream straighteners. By the way, Ray and I have been friends a long time. He used to love stream straighteners. And I'm like, Ray, man, the first thing you do is break the stream up. Why? He's like, I just like the way it looks. So like, I think it's important on reach. And I'm like, I was ordering the smallest tip for Oakland, and we had older shutoffs that were split balls. I didn't even care. Like, the whole split ball deal is like, I was like, for the 1 3/4 line, it really, like, the little bit of imperceptible difference, like, I was like, whatever, I'd rather get the nozzles out and we'll figure it out as it goes. So back to the clogging deal. It'll pass a quarter, a 15/16 tip can't pass a quarter, and then it'll pass a 5/8 inch bearing. And a 5/8 inch bearing, the impeller of a 10.5 inch or smaller impeller, whether it's water, Starley, or whatever, that cross section, it won't pass more than a 5/8 inch bearing. So in other words, there's nothing that can come through the pump that can't go through this. I was very deliberate when we designed it.
Right.
You know, and that's it. Now, people will go like, what about a potato chip bag, or what about a glove, or what about, right? And I mean, we can play that game all day long. It's not designed to go on standpipe systems. You know, like it's not. Now, here's a little bit of a mind F for you. Guess what's in a lot of standpipe systems? PRVs, right?
No, without a doubt.
Okay, how open do PRVs get, bro?
Oh, brother, you're way out of my wheelhouse at this point.
Tiny.
Like quarter inch, you're saying 3/8? What are you saying?
If you pump into an FTC and there's a glove in there or there's debris in there, it's going to block the whole freaking outlet. So where are we really worried about debris and standpipes? What type of standpipe systems?
No, I'm just throwing at you the things that people have said.
I'm just.
I know you have heard it. Like you've heard it dozens of times.
Actually, I'm not busting your balls. This is beyond the turbo. If you're ever interacting with the dry standpipe system, that's when you really want to pay attention to your flush, and you want it to be laminar. Why do you want it? If it's a dry standpipe system, the first thing I would do is open it up when I would get there and lay my tools out. And if I had a gate valve, I would have put it on there. I want first water to come out of my outlet. If I can beat the guy charging it, why? I want my debris to come out. And then when you're climbing up the stairs on a dry standpipe system, what does the attack crew have to do on the way up? You got to visualize every standpipe outlet. Is it capped? Is it not capped? Is the stem open or shut? My engine company carried extra caps because, like, sometimes you'd see a stem that's open and it's missing what? It's missing the hand wheel. So what am I going to do? Am I going to sit there with my pipe wrench and try to assign a firefighter to close this, or I'm just going to screw a cap on there and move on?
Gotcha.
Right.
Gotcha.
So makes sense. So why do we flush wet barrel hydrants? Now, dry barrel hydrant, why are you supposed to open it gently, go to the largest outlet, lowest outlet, and only fill the nozzle halfway? Why are you supposed to gently flush it first?
We don't have a dry barrel. I've never even heard of this. You're teaching me stuff right now. So go ahead.
A dry barrel hydrant is the hydrant that's below the free line. You probably have a dry hydrant, right? So you probably have that. Wet barrels, West Coast, temperate climates, right? The worry is that a kid puts what in there? Debris, like matchbox cars, gloves, potato chips bags. So you don't want to aggressively flush your dry barrel hydrants, because where's all that debris go? To the top of the bonnet. To the top of the bonnet. By the way, what else? Ice. If you open a dry barrel hydrant, ice floats. It can get stuck at the top of the bonnet. You shut it down. It's too big to leave. You hook up your flowing lines. That ice comes up and blocks the hydrant. You get low intake pressure. What happens? Your rig goes to idle. I personally think that may have been a contributing factor at Black Sunday. Because they could never get the rigs to reproduce what occurred there. And it was an extremely cold day. They said they might have had ice in the line. They had a rig go back to idle several times. And the only way I could reproduce it was put a piece of styrofoam in a dry barrel hydrant. Like, I went out and did it just because I was curious. Right? I was just like, why would a rig go to idle? Why couldn't they reproduce this? It had to be on the intake side, right? So I was trying to think, like, by the way, do I have any freezing issues in the city of Oakland? We had 3 dry barrel hydrants in the entire city. So back to standpipes. So now you're flushing a dry barrel system, dry system gently. You want to get all the debris out of it. How long do you flush other standpipe operations? Are you looking for clean water? You know that black water that comes out with all that? When is clear enough? can black water put out black fire, as Ray would say.
Right.
You're not actually, you're looking for pressure and volume out. You're not really trying to get all the scale out. What does a standpipe nozzle have to be? Self-flushing. And it doesn't have to be self-flushing for the big debris. It has to be self-flushing for the scale. That's another thing around, like Brent Brooks was like, oh yeah, a head nozzle, it can be standpipe approved. And I was like, well, that's true. Like that's a bladed nozzle. It's just a hole you can look through. So it's a self-flushing nozzle.
Right on.
So
I love it, brother. Man, again, yeah, absolutely an education, and people are trying.
I'm sure there's more questions.
Oh, there's a ton, but I'm going to go to one of my favorites, which is, what book or books do you think firefighters should be reading? Doesn't have to be firefighting books. It can be anything, but what books do you think firefighters should be reading? It's one of my favorite questions I ask.
Yeah, that's a tough one for me. You know, like I have standards that I really like. I mean, Clark, Principle of Firefighting Practices, it's out of print, but it's really good. I think most people have read John Norman's book, you know.
Oh yeah, the Blue Book and John Norman. I don't care what edition, but absolutely.
The Blue Book's is a very valuable book that I think probably doesn't get discussed enough.
No, I'm with you. Willie Clark and John Norman. Is that what you're going with? I don't know.
No,
I don't want to cut you off.
No, those are two. You know, like I think that those two books are extremely valuable. You know, and Dave Furnell, he does have the reprint kind of like in review. I don't know if Fire Engineering will put it out. You know, I don't know if it's up to date enough to them, but obviously, you know, Fire Stream and Practices by Furnell. And like, but these are probably things that I've said before. What would be like something new? You know, like I'll think. Give me a minute. I'll think about it. I'm trying to think of anything new that I've read that might be a worthwhile endeavor. Volume. Let's go back to volume in large spaces, right? So I think what's not being talked about a lot on the fire ground is geometric shapes of buildings. Like if you had like an L-shaped building, let's say you had like a shop and it was like 50, let's say 60 by 100 and 60 by 100, and it's like an L shape, and you have signs of fire throughout, and you know it's one space. It would probably be better to enter on the ends, right? The two initial hand lines should apply through the man doors at the two ends of the L, and then have a third one pick up the center, right? If there was a man door in the center. And the reasons you'd start at the ends first, because your stream would be narrow and long, and the center would be just the piece that you're missing. So like, kind of like imagine gigantic grass fields and you're trying to get everything wet. A lot of the opposing handline stuff that is in dogma around residential fires is inappropriate thought processes on commercial fire grounds. Like you want to look at the building more holistically. And typically I would argue that you want to start where you think the origin is and work the closest entry to that. And, you know, these are hard lessons learned. Like if you look at like the Charleston 9 or other fires and that's a really interesting building because people don't realize this. It was added onto so many times that It just stayed below the sprinkler code the entire time. But, you know, like if you can't enter from two different spots, so like a strip mall with a lot of fire coming out the front, have you ever seen that smooth bore pattern that's going through a large vent point ignition and there's just a continuous amount of fire coming out of there? Sure. And it's like a guy kind of like resting there and there's fire coming out.
Yeah.
Have you ever thought that he might have actually put the fire out that he's hitting? Well, think about it. If you're in a smoothbore
I love
nozzle,
playing hypothetical here, but no,
Yeah.
I haven't.
if you're in an inch and an eighth and you have, like, let's say 80 feet of reach, and a guy gets up 20 feet from the window and he's going back and forth, he might have put out the back 40. And that vent point ignition, what are smoothbore nozzles extremely poor at? In a non-distributed environment, it's up to the nozzleman to be the sprinkler head. That's why I do all that training with the slow Z, left and right, all the way down. And then I say whip it as hard as you can on the way back, because I'm trying to get that water to fall out early. And then I learned it from Jeff. I think he teaches it mainly as an aid on nozzle reaction moving forward. But I think half bailing moving forward gets a pre-distribution where you're going next. So here, Chief, at your next strip mall fire, right, when you have a guy with a handline up front, what's that little stem wall prevent? That stem wall prevents you collecting.
Getting low.
So the first line, bring two couplings forward, bring the nozzle back about breakover distance. So let's say you have 80 feet of reach on the drill ground, breakover at 40. So get back about 30 feet, the initial nozzle. What's good about that? Is their gear getting saturated? No. Are they in the collapse zone? Probably not.
Probably have it.
Right? Where is their water initially going to enter the building? At or near breakover, what's their initial extinguishment?
So it's gonna hit and break down, yeah.
Right where they want to go next, right? So now you're the second engine on scene. You're pulling your 2.5 to support that 2.5. Let's say this is the kind of building you can't get around to the Charlie side, or there's attached exposures in their firewalls. Should that nozzleman line his nozzle right up next to that guy's nozzle? No. That water's entering at breakover. Where should he be? Or she? They should be like 20 feet forward, because that water's going to fall where? In the back of the strip mall. So they should be like this. They shouldn't be together. They should be staggered. You're looking for a different footprint of extinguishment. And I know it's going to sound like I'm just harping, so back to patterns, back to movements and stuff. I think the bladed pattern is going to be a heavy hitter in non-distributed environments. I mean, think of a paper aisle. Like if you went to a deck fire on the back of someone's house and you had lots of decking on fire, right? We've all been there, right? You're using the reach of the stream. You're like Tasmanian devil. You're knocking all around. Once you get the deck mainly extinguished and you get up on it, are you leaving that smoothbore nozzle wide open?
No.
No, you're like half bail. Let's get everything. Did it break the sliding glass window? Do we need to get back inside? My advice for this on Charlie side decks is always to drop the line and deploy another line. For two reasons. I think it's too hard to redeploy a line to the alpha side. And the other thing is, what's that line actually technically there doing? It's almost a safety, especially if it's broken one of those windows and the fire's got inside. You have a Charlie line that is charged and present, right? The engineer could have stretched another one. But back to this deck, right? Imagine the same exact fire with a concentrated edge where you could just go swipe, 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 and get a whole bunch of the deck. Now go inside in a place where your stream is not going to hit a surface. The nearest surface your stream's going to hit, the wall is way far away, and you have a bunch of racking on fire, right? The bladed pattern. All right, not everyone's going to have a bladed pattern. How can we get some of this without a bladed pattern? All right, you go in with a 2.5 and you knock the piss out of it, right? And you want another line to your location. What's it supposed to be? What's the old mantra? Equal or greater, bro. Always get equal or greater. Does that make any sense? If your 2.5-inch handline just took out the bulk of the fire, think about FDNY's new engine book. Why do they allow 1 3/4 hose into commercials? mobility, and placement. So what should you always ask for when you ask for another line? Exactly what you want. Hey, I need a 6-length stretch, 1 3/4 to the Alpha Bravo corner. The Chief gets on. Hey, it's a commercial. You don't want a 2.5? No, I asked what I asked for. We got it knocked. We need a line to do what now? Go through all the racking. Now, hopefully it's never the other way. You've stretched a line with too little knockdown power and you're asking for a bigger line. But guess what? If you do that, ask for the larger line. Could you ask for a heavier piece of equipment? Could you be inside with a 2.5 and ask for a RAM monitor to your location? Inside. Sure, you could do that. What's the nicest thing about a RAM monitor? Sorry, Corley, you're just stuck answering these questions.
Yeah.
It has a shutoff on it. You could bring one coupling forward, right? So again, volume, placement, and velocity, right? I want people calling for RAM monitors inside. I want people bringing one coupling forward. I want them to know what a RAM monitor can do inside, right? I want someone that has done a good job with the 2.5 not to be afraid to call for an 1 3/4.
Rock and roll, brother. Rock and roll. And that officially brings it 248 in the books. Dennis Legear, man, thank you for spending your time with us this evening. If someone wants to get a hold of you, what's the best way to do that?
Dennis Legear, Dennis at hydrantsandnozzles.com. Just Google it. I feel like I did a lot of lecturing here. I apologize, Corley.
You did a lot of lecturing, and it was very valuable to those who want to get that value out of it.
Yeah, I'm just gonna close it out. Volume, placement, and velocity. Remember that 500 GPM RAM monitor is a much higher speed. It's going to do a lot more damage than 2.5s. It's okay to bring it inside. It's okay to call for that smaller line.
Yep.
It's okay to have opposing streams. It's those 3 critical things. And master streams have too much volume, too little velocity, and handline stretches need to be based on what you need at what time. With some general rules around. I still believe in 2.5 in commercials and larger spaces. I'm just saying if you get a good knock, you often don't need another 2.5. You need something smaller and more mobile. And I appreciate the bully pulpit, Corley. You've done a great thing for the fire service here with the scrap and your management book and stuff. And
hey, thank you for being on here tonight, Dennis. It has been an experience. Coming up this Saturday is Mega Scrap Echo. It is going to be 2 in, 2 out. That's what we're going to talk about. The new CFR is being revisited. It's time to make the fire service voice heard. Tune in this Saturday, June 1st, for Mega Scrap Echo. Scott Thompson, Nick Ledeen, and Sean Duffy. That is a badass lineup. You will not want to miss these episodes because 2024 is going to continue rolling in style. Thank you, Dennis Legear, for spending your evening with us and sharing your knowledge. The audience, man, you make the scrap magical. You asked a lot of great questions tonight. I could not keep up. I will not be lying to you. I could not keep up. But the scrap would not exist without you being here. Thank you for tuning in live. I love you all. Remember, mutts don't scrap. I hope the tones stay silent unless it is burning. Everybody, stay safe out there.